Hello guys, and this is kind of 5G PDU. PDU is Protocol Data Unit Session Establishment Flow. And if you are coming from an EPC background, so this is kind of equivalent to legacy PDN connection setup. And like we have divided this PDU session into some phases. So here like the phase 1 is the PDU session establishment request only. Here like a UE is deciding like it need to reach to the internet or a private enterprise network. Okay, so the UE encapsulate it in NAS PDU session establishment request inside an RRC message, which is like G node B is going to forward that to AMF via NGAP uplink NAS transport. And like inside that NAS request detail, you could have that PDU session ID that is created, or you can say some random number. And then we have request type as initial request. PDU session could be IPv4, IPv6, or IPv4v6. That means it is kind of dual stack. Then we have NSSI and DNN as well. So DNN can be some private internet or internet, something like that. So in the next phase, like we will discuss like how AMF is going to select the SMF, and we already covered that in our other video as well. Now like here AMF receives the request, but the AMF doesn't handle that particular IP routing for that particular request. So it need to select the appropriate SMF, and for that it use NRF discovery logic. So and after that so it get the SMF details. Okay, after that it will be sending that NSMF PDU session create SM or session management context request, and that includes PPI PDU session ID, SNSSH and DNN. And apart from that request type, it can include user location or TAI, it can be there, and then the access type. And next one then SMF is to do the authorization, so it will queries the UDM to get or you can say to ask does this subscriber is actually pay for the access the specific DNN on which that particular user is asking. And for that UDM responds with the allowed QoS profiles and the maximum allowed bandwidth, and that is a session AMBR, you can say. So here you can say subscribe QoS and session AMBR, and allowed PDU type either it is IPv4, IPv6, or some dual stack or some Ethernet kind of PDU types are also allowed in 5G. And in the next step, there will be session management policy association. So here SMF is going to retrieve the dynamic policy rules. Okay, so it could be like QoS charging, and it is asking for from the PCF. So here SMF will form one API call, that is NPCF SM policy control and the create request. So it will be sending SUPI, PDU session ID, DNN, NSSI, and then IPv4, IPv6 kind of PDU type, and then it will be getting SM policy control create response, and here it will be having that PCC rules for that particular session and default QoS and the session AMBR. So here the PCF act as a policy brain, so returning that specific PCC rules. Okay, telling exactly how the data session should be metered for billing and what priority it gets on the network. The next phase is kind of UPF selection and N4 session setup. So here N4 session setup, you can say now SMF has the authorization and the rules. Okay, it needs a physical gateway to actually route those particular packets. So SMS selects the optimal UPF, often like it could be based on geographical proximity to the user's current location to reduce latency or some other parameters as well, you can see. And also like SMF is going to allocate IPv4 or IPv6 address for the UE, and SMF pushes the routing rules down to the UPF over N4 interface using the PFCP protocol. So it sends the N4 session establishment request, which contains PDR that tests packet detection rules. Like it tells how the UPS should identify the user's traffic, and also there could be FAR as well. FAR is forwarding action rules, like where the UPS should route the traffic once it is identified. And here then the UPF accept that particular request, okay, and like responds with the UPF N3 tunnel endpoint identifier and the IP address. And now the SMF must pass like this particular details down to the network uh, towards the G node B and UE. So now let's move to the next slide for this PDU session establishment procedure. So here like the next phase will be kind of N1 N2 message transfer. So here like SMF is going to prepare session accept, okay. So SMF is going to construct the NAS accept message N1 and NGP configuration parameter N2. So now here SMF has all the routing details, but it doesn't talk directly to the G node B or the UE. So it is going to use AMF as a proxy. So SMF construct the payloads and send it to the AMF via an AMF communication N1 N2 message transfer. Okay, so inside that it will include PDU session ID, then N2 like SM information or session management information for the N2 interface. It could be UPF entry tunnel ID, QoS profiles, and session MBR. It also includes N1 information or like NAS information that is like going to the UE. So here like N1 information could be PDU session ID, then allocated IP addresses or IPv6, okay, then QoS rules and SSC mode, like there are three SSC modes like for that particular session. Suppose it is selecting that mode 1. Okay, so now the next phase is the PDU session resource setup, or you can say N3 tunnel N3 tunnel N3 downlink tunnel. So here like MF is going to send the NGV PDU session setup request, and it will include the N2 setup information, and also like it will accept that particular session request, and it will be sending to G node B, and then the reader bearer setup should be there, or DRB bearer should be like created for that particular flow. So for that, like the RRC connection message should be flowing from G node B to the UE, and it will contain the DRB's setup and like QoS flow mapping. And inside NAS as well, like PDU session establishment request, you can say accept that it is getting from AMF. It will like transparently forwarding that to the UE, and then like UE is also going to do that binding, okay. So you can say like it extracts the new IP address, binds it to the network interface, and like applies the routing rules. At the kind of exact moment, you can actually start transmitting the actual uplink data as well. So here like the G node B knows like UPF tunnel endpoint identifier from the N2 envelope. So it can route packets kind of outwards. However, like but you can say UPF is still blind to the G node B. Means like the downlink it is still not happening. Okay, so then comes the phase number 3. Now it is like we need to complete the entry tunnel. Like uplink is okay, that we need to complete the downlink. Okay, so you can say to achieve the bi-directional traffic, the network must send the G-node B address back to the UPF. Okay, so here like the G-node B replies to the EMF with the NGAP PDU session resource setup response, and inside that message it will add that an entry tunnel identifier and the accepted QS flow, and AMF forwards that identifier to the SMF via PDU session update SM context request. And here like SMS executes like SN, you can say N4 session management modification, and that request is going down to the UPF, and like here UPF is going to acknowledge that particular update, and it will be like sending the response like it is updated its kind of data for that particular flow. And in the last phase we have the bidirectional user plane traffic flow. So here like the circuit is complete. Okay, now the UPF knows exactly which G-node B's tunnel identifiers are there, like corresponding to that specific user IP address, and any data hitting the UPF from the internet is encapsulated in G2PU protocol, and like going across the N3 tunnel directly to the G-node B, and G-node B strips the GTP header and transmit the IP packet over the data radio bearers to the U. And like that's it from this PDU session establishment. And like thanks for joining this session. I will meet you in next session. Thanks.